We have a number. The number is 237.75 base 10, and we need to find the XS3 code of this particular thing. We need to find XS3 equivalent of this particular number. So take 5 minutes of time, or it's a simple question only. Take 1 minute of time, and please let me know the solution. Okay. XS3 code we haven't discussed it, right, in our sessions. XS3 we haven't discussed it, right, in our session. Okay. So if you know how to solve this, you can solve, or else you can leave it. We haven't discussed this particular concept yet. Let's say you have a number 135 base 6 plus 144 base 6, and which is equal to 323 to the base 6. We need to find the value of x. So you can try this one. So we have a number 135 base x plus 144 base x plus 323 base x. We need to find the value of x. Take your time and try this one. Okay, so I will also parallelly start solving this question. Okay, so how to approach this particular type of questions. So what we are going to do is we will need to convert this number into base 10 numbers. So how to convert them? That is 5 into x power 0 plus 3 into x plus x square plus x square plus 4x plus 4, which is equal to 3x square plus 2x plus 3. Okay, so it is nothing but 2x square plus 3x 4x 7x plus 9, which is equal to 3x square plus 2x plus 3. And if we solve this, which is nothing but x square minus 5x minus 6, which is equal to 0. So what are the roots of this equation? So we can simply write it as 6 into x plus 1 minus 6 into x plus 1, which is equal to 0. So x is equal to minus 1 and x is equal to 6 we are getting, right? So which root we should select? Whether we should select x is equal to minus 1 or whether we should select x is equal to 6. What we should select? Obviously 6, because the base should be a positive number. So the base of this is x is equal to 6. Okay. Yes. So one more question. So the number of ones in 8-bit representation, the number of ones in 8-bit representation of minus 127 in 2's complement form, let this be equal to m, and the number of ones in 8-bit representation of minus 127 in 1's complement, it is equal to n. So we need to find m is to n. This is our question. So the number of ones in 8-bit representation of minus 127 in 2's complement, let's say it is m, and the number of ones in 8-bit representation of minus 127 in 1's complement, let's say it is n. So we need to find m is to n. Okay, take your time and please provide the answer. So first we should represent our minus 127 in 2's complement form. So minus 127. So first of all, plus 127 base 10 in binary, which is nothing but 0 followed by 7 ones. 1, 2, 3, 4, 5, 6, 7 ones. Okay, base 2. And if we convert this into 2's complement form, then it is nothing but 1, 0, 0, 0, 0, 0, 0, 1. Okay, so this is your 2's complement form. And it is basically having two number of ones. So here m is equal to 2, and plus 127 in 1's complement form. In 1's complement form is nothing but 1 followed by 000 000 0. Okay, so here the value of n is equal to 1. So m is to n is nothing but 1 is to 2. Okay, is this clear for everyone? So here basically minus 127. So the number of ones in 8-bit representation of minus 127. So in 2's complement form is m. Okay, so what you should do is you should perform 2's complement on this particular number. That will give you the number of it will give you some value. You need to find the number of ones in that particular 2's complement form. That is nothing but m, and the number of ones in 1's complement form of this number is nothing but n. And here they have represented clearly that we need 8-bit representation. Okay, so what you're going to do, first of all, you are going to write down the 8-bit representation, 8-bit binary equivalent of decimal number 127. That is 0 followed by 7 ones is nothing but your 127 value in binary. Now what you're going to do, you are going to perform 2's complement on this number. Okay, so if you perform 2's complement on this value, then what is your binary equivalent? That is nothing but 1 followed by 000 Now how many ones are there in this number? There are two number of ones. So that is nothing but equal to m. Okay, so in the question also they have given it. M is nothing but the number of ones in 2's complement of minus 127. Okay, and plus 127 base 10. If you apply again 1's complement on this number, this is your value. And in the 1's complement you have only one. Okay, only one. That is nothing but it is equal to n. So m is to n, that is nothing but 2 is to 1. So we have a number 4 into 4096 plus 9 into 256 plus 7 into 16 plus 5. Okay, so we need to find how many ones are there in the binary representation of this number. How many ones are present? Others, anyone got the answer? So the answer is 8. Okay, so let's see. So for solving this, you can follow this particular trick. So what you can do is you can convert these numbers into powers of 2. So for converting, why I'm taking the powers of 2? Because if you observe, in the case of 2, the 2 is nothing but 1 0. If you take 2 square, that is nothing but 4, that is nothing but 100. Okay, and if you take 2 cube, which is nothing but 1000, which is also having only one number of 1. So if you convert this number into powers of 2, then it will be easy for you to find out how many number of ones are there. Okay, so what I'm doing basically, so 4 into 4096, I can replace it by 2 square into 4096 means 2 power 10, 2 power 12, I think. Yeah, 2 power 12. Okay, plus, and this one, so 9 can be written as 2 power 3 plus 1, 2 power 3 plus 1, and into 2 power 3 plus 1 into 256 means I think it's 2 power 7, 2 power 8. Okay, 2 power 8 plus, and this what you can represent 7 again, 2 square, 4, 2 power 3, 8, 2 square plus 3, you can represent it as 2 square plus 3, 2 square plus 3 into 2 power 4, 16. Okay, and finally 5 is nothing but 2 square plus 1 plus 2 square plus 1. Okay, so I'm rearranging this equation in the powers of 2. Okay, now if I again simplify this, it will become 2 power 14 plus 2 power 3 plus 2 power 8, that is 2 power 11, and here 2 power 4 plus 2 power 2 power 11, and 2 power 8 plus 2 power 8 plus 2 power 7, sorry, 2 power 6, and what else we have, 2 power 4 plus 2 square, and we will get 1. Okay, so 1 2 3 4 5 6, let me check, 2 power 4, 2 power 11, 2 power 8, 2 power 6, and if I simplify this, I will get one more term, 2 power 5, I will get, yeah, so 1 2 3 4 5 6 7, and this one 8. Okay, so total 8 number of ones. So is this clear for everyone? Or else what you can do is you can convert the entire number into base 16, and from that base 16 you can convert that number into binary number. Okay, like that also you can do. Okay, so let's say if we have a number 1001 which is represented in 4-bit 2's complement form, so whether it is a positive number or negative number. So let's say if we have a number which is written as 1001, so whether it is a and what I am saying is it is a uh, it is represented in 4-bit 2's complement form. Can anyone tell me 4-bit 2's complement form? Can anyone tell me whether it is a positive number or whether it is a negative number? So what is my question is, I have represented a number 1001 in 4-bit 2's complement form. So whether it is a positive number or whether it is a negative number is my question. It's a negative number. So why it's a negative number? So in our previous sessions also I have told you, if we are representing any number in 2's complement form, then the MSB is playing a key role for finding out whether the number is a positive number or whether the number is a negative number. So here the MSB is 1, so it is a negative number. Okay. So if you're having doubt, you can see, you can convert any negative number. Like let's say suppose if you have -3, so basically +3 is nothing but 0, 1, 1. Okay, if you convert this into 2's complement form, then if you want to represent -3, then you are going to apply 2's complement on this. That is nothing but 1, 0, 1. It is nothing but 1, 0, 1. So for every negative number which you are going to represent in 2's complement form, the MSB will have 1, and for positive numbers you will have 0 at the MSB. Okay, so this is how you can decide whether a number is positive or whether a number is negative. If it is declared in 2's complement form, you can judge according to the sign. Okay, so you can judge whether it is a positive number or whether it is a negative number.